Oh, by now you should have downloaded the document that goes with these notes. You can either print it or you can type your answers to the questions on that document. And that's what you're going to submit to Canvas after you're finished with all these notes. So let's get started. So as you're listening to this, you can feel free to pause the video so you can write everything. You can listen to sections of it again. And just take your time and be thorough in your answers. Okay, here we go. So I want you to think back to our unit on ecology and biodiversity and the cycling of nutrients in a natural system. Really, you can think about this quote. So there's the law of conservation of mass. So matter cannot be created or destroyed. It only changes form. So all those atoms get used over and over in different molecules. So in a natural system, everything cycles through the system. There is no waste in nature. And think about when a fire burns plants. The carbon molecules that are in the plants, they go into the air when they're burned as carbon dioxide and also water vapor. And then there's going to be some ash left over. Those are all the non-burnable, non-combustible minerals, such as potassium, nitrogen. They're going to be left behind in the ash, and that acts as fertilizer for the new plants that grow. So nothing is wasted in nature. Everything cycles. So, but what about human-generated waste? How are we nothing like a natural system? But let's take a look at what our waste stream looks like. This is data from the U.S. Environmental Protection Agency from 2018. We produce in the U.S. a total of about 292 million tons of solid waste per year. That's about 4.9 pounds per person per day. That's a lot of waste. So what's in that waste stream? So let's take a look. A lot of it comes from mining and oil production, from agriculture, from industry. There's sewage sludge, and a very small percentage is what we call municipal solid waste. That's what you probably think of when you think of waste. What do you put into your trash can, into your recycling cans? So let's take a look at what our solid waste looks like in this country. Good part of it is agricultural waste. So it's the leftovers after plants have been processed. A lot of the plants we don't eat. And so the leftovers are solid waste. Mining waste, all the rock, the soil that has to get moved to mine. Think back to our mining unit. That all becomes part of our waste stream. Industrial waste. This is all sorts of material left over from manufacturing processes. And it could be liquid or it could be solid. And it's a vast variety of different types of chemicals. Municipal solid waste. This is what leaves your house, what leaves office buildings, all the garbage that you take out to the curb or put into a dumpster each week. And then sewage sludge. We go on a field trip to a wastewater treatment facility near us. And so you will see this in person. This is the solid material that goes down our toilets, our drains, and finally is cleaned up at a wastewater treatment facility. So here's a pie graph of what our municipal solid waste looks like. So remember, that's only a small fraction of all the waste produced in the U.S. This comes from the U.S. EPA. It's for 2018. And I want you to look through this list of materials. And I'm going to start on the right-hand side and work my way around to the left-hand side. What's actually should go to a landfill? What is not recyclable, not compostable? So paper and paperboard, recyclable. It's a huge percentage of our municipal waste. Glass, that's recyclable. Metal, recyclable. Plastic, depends on what type. Some are recyclable. Yard trimmings, that's compostable. Food, oh my gosh, 21.59% of our solid waste is food. That's compostable. Wood is compostable. Rubber and leather, possibly compostable. Textiles, some will be compostable. But very little should actually go to a landfill. And yet, the majority of this waste, even what is recyclable, will end up at a landfill. But let's take a look at how we dispose of waste. What used to happen is people would put their waste in open dumps. So, imagine hundreds of years ago, what was people's waste? It was mostly food, agricultural waste, maybe some broken pottery, some clothing that just wasn't repairable anymore. They just carried it to the outskirts of their village and they left it there. But it wasn't a problem because everything was compostable back then, except maybe the pottery, but there wasn't that much. People didn't waste much. So now, open dumps today are not a good idea because remember all that food that's in the waste? Well, that's going to attract wild animals. Plus, it's just not very pretty to look at, so it's not aesthetically pleasing. Could have toxic materials in it, and that just soaks right into the ground and the groundwater. So it is illegal in most developed countries. You still see this kind of thing in a lot of low-income countries, however. So this one is in Barrow, Alaska, no longer legal in the US. This is an old picture, but you do see things like this in other countries. Now, how do we dispose of things today? We use something called sanitary landfills. So these are large excavated pits, and the bottom is clay, which, think back to our soil unit. Clay is very impervious to liquids going through. So the best place to put a sanitary landfill is somewhere with clay soil. But you also line it with a very thick plastic liner because you don't want any water that gets into the landfill to make it down into the ground. So we want it, that liquid that can go through the landfill is called leachate. We don't want that leachate getting into the water table below, into the groundwater. So every day the refuse is compacted and it's covered with a layer of soil. So here's what it looks like. The trucks come in, they dump their waste that they've collected at homes of businesses, and it's all compacted with heavy machinery, and then soil is placed on top. So, and notice the plastic liner at the bottom. That's to stop the leachate. And then it's actually quite high tech. Underneath the landfill, there's pipes to collect any leachate that might make it through. And there are pipes to collect any fluids that are inside, because remember, this is just layers of soil and garbage. So when it rains, rain is going to get into the landfill. So it needs to be collected and it can't make it out. We don't know what's in there. Whatever toxic materials people threw in, because they don't sort through the solid waste. If you put it in your gray can to go to the garbage, it does not get sorted. So whatever you put in there, even if it's something that does not belong because it's toxic, it's going into the landfill. And you remember all that organic material, the yard waste, the wood, the food. Well, what happens when it's organic material is decomposed in anaerobic conditions, so no oxygen, methane is produced. So the methane is collected, and usually they use it to power buildings. It's natural gas, that's methane. So it is collected and can use to power the buildings. Sometimes it's just burned off. You'll see a pipe and you'll see flames. Not a great idea. You might as well use that methane for something. Sorry, my dog is making lots of noise right now. Another option is to burn the garbage. So this is usually in communities where they don't have a lot of space for a sanitary landfill, or Hawaii. They burn most of their garbage because they are so far out in the ocean. They're not too worried about the air pollution that can be left over from incineration. So the good thing about this is it does reduce the volume of the solid waste a lot, but the ash that's left over can be really toxic. So here's a picture in Baltimore. A lot of the East Coast, they don't have enough room for landfills. So they can sometimes burn their waste. And then you make electricity from burning the waste. That's good, but you don't really know what you're burning because people throw all sorts of terrible things into the garbage. And then that ash that's left over from the burning has to go to a landfill. And because it's toxic, it can't just go to any landfill. It needs to go to a landfill that's very carefully designed for hazardous waste. So there's different kinds of incinerators. Sometimes they call it refuse derived fuel. So they take out everything that could be recyclable and whatever's unburnable. So metals, glass, aluminum, those would all be taken out. And the burnable material is turned into pellets. Then those pellets can be thrown into a coal-fired power plant. So that power plant could use either coal or these pellets, and then it's used to generate electricity. So this is less air pollution because it is sorted before it's burned. So they'll pull out unburnable material and also toxic materials that they find. A mass burn, that is different. They don't sort it at all. It's anything that's smaller than large pieces of furniture and appliances. It's going in and it's going to get burned. So this one creates a lot of air pollution problems. And then the ash is more likely to have toxic materials in it. So what we want to try to do is to shrink the waste stream. And remember that graph at the beginning? We can shrink our waste stream a lot. The vast majority of the solid waste we produce in this country is either recyclable or compostable. So by recycling, instead of tossing materials into a landfill, never to be seen again, instead you turn them into new and useful products. It's a lot less expensive than producing material from products from new materials. It reduces the space needed for landfills. So an example, Japan, think an island nation with a lot of people, they are very good at recycling, and they recycle about half of their waste, much better than the United States does. It also lowers the demand for raw resources. So you don't have to go out and do as much mining because a lot of that metal you get from recyclables. And then you save a lot of energy and produce less air pollution. So here's a graph showing the percent that we recycle. So auto batteries, the reason why we recycle almost 100% of auto batteries is when you go buy a new battery, you have to pay a deposit of $15. And when you bring your old battery back, you get your $15. So most people want their $15 back. So they make sure they bring back the battery. And we want to make sure we recycle those batteries because they're full of lead. And we don't want lead getting into groundwater. And then all sorts of different metals are more likely to get recycled because you can get paid money for bringing those in. So, and then it just goes down. Tires, very difficult to reuse tires. And plastic. Plastic is especially different. We'll talk about that later. So here's an example of the benefits of recycling. If you recycle 1 ton of aluminum, that saves 4 tons of bauxite. That's the ore that aluminum is made from. 700 kilograms of petroleum coke, which is used in the processing, and also pitch. And it keeps 35 kilograms of aluminum fluoride out of the air. So, and producing aluminum from scrap instead of the ore, the bauxite ore, cuts energy use by 95%. Why in the world do people throw away aluminum cans? It just makes so much sense to recycle them. Now, recycling is not perfect. It can be really, really difficult. So one big problem is the market prices fluctuate. Sometimes you can make a lot of money from aluminum, let's say, and other times the prices are low. And it's really hard for a business to function when they don't really know how much money they're going to make month to month. There's some items, like for instance, paper, it's really limited in how many times it can be recycled. So paper, the fibers get shorter every time they're recycled. And finally, they're so low quality because the fibers are so short that it can't be recycled anymore. So we call that downcycling. And then recycled materials have to be separated by type. So you either have to get people in their homes and businesses to separate, or you need to pay employees to separate. And then it's especially difficult with plastics. There are 7 different kinds of plastics, and some of them, 1 and 2, are more easily recycled than the rest of them. So, and then a lot of plastic items that you buy, they're actually a mix of the 7 different types of plastic. And you can't tell that by looking at it. And if they mix the wrong kind of plastic in, then it can contaminate all of the plastic they're trying to recycle. So each type of plastic has to be separated before the recycling process starts. Now, composting, another great way to shrink the waste stream. So we're just mimicking nature. Take bacteria and fungus and add lots of oxygen, and they will break down all the plant and animal material. So of course, this only works for organic material, for living things. Another big issue is just reducing the amount of waste we make. So the best way to deal with our solid waste is just not to make it in the first place. So, and one of our big problems is excess packaging, like you can see in this picture, how many different layers of packaging there are. And imagine that frozen dinner, a group of them also came in a box to the grocery store. And then the grocery store opens the box, puts them all in the freezer, and now they've got to dispose of that box. There's a lot of waste. So one method for dealing with all this waste is called integrated waste management. So this is arranging the strategies in an order to reduce the amount of waste that goes into the landfill. So kind of the way most communities deal with it right now, most of the waste goes into the landfill. That's not what we want. And then, they do try to convert some materials to other materials and recycle and compost and reduce the waste. but for the most part, most goes into the landfill. So that's the triangle on the left-hand side. But what we need to do is change it to the triangle on the right-hand side, where we try to just reduce the production of waste in the first place. That's our number one thing we do. And then we try to maximize recycling and composting of everything else. And then we try to convert materials into something that is useful. The very last thing is landfill. And that should be minimized because we don't want to fill up the landfills because we don't know what kind of toxic materials are in there, and we don't want to use our land that way and all the fossil fuels it takes to cart it over there and then monitoring it forevermore because of the leachate. So not to mention the methane production. So we minimize what goes into the landfill by using these other methods first. So how can we reduce waste? Well, here's a list of topics. So one thing is redesign manufacturing processes. Here's a job for some of you. So then you make less materials and use less energy and produce less waste and pollution. Another option is produce products that can be repaired, reused, composted, or recycled. Think about items that you've had in your house and they break and they're just unfixable. They're made to be unfixable because the manufacturer wants you to go buy another one. That's how they make money, selling more. They don't make as much money if they make it so you can fix it when it breaks. So we need to demand that products can be repaired. And then eliminate or reduce the unnecessary packaging. And boy, our mail order life now doesn't work well because now it's not just what gets sent to the grocery store or the pharmacy or whatever that's in a box. You order it online and it arrives in a box. We have more boxes than ever to dispose of. Another thing that should be done is you pay for your waste collection, the garbage, the gray can in our case, but the recycling is free. And that's what Marine Sanitary does here. They're a great example of integrated integrated waste management, where you try to reduce the waste as much as possible and increase the composting and recycling. So it is free to have your green bin picked up and your recycling bin, but you do have to pay for your waste bin. And then last option is make companies have what we call cradle to grave responsibility. They are responsible for, they make the product, and when that product is at the end of its useful life, they have to take it back and dispose of it properly. And then they will make things more recyclable because they don't want to get their products back. I would like you to pause this video and take a look at this video about the Great Pacific Garbage Dump. So you can find the link to this video on your document. Just click on it and watch the video, write notes in the table. So now let's take a look at another topic, that's hazardous waste. So first of all, you need to know what hazardous waste is. It can be a liquid or a solid, and it can meet any of these criteria. So it can be fatal to humans or laboratory animals in low doses. Lots of things are fatal in high doses. This has got to be in low doses. It can be toxic, which means it can make you sick. It can be carcinogenic, that means it causes cancer. Mutagenic, it mutates DNA. Or teratogenic, so that means it disturbs the development of a fetus. So, and that could be to humans or to other life forms, usually animals. We usually test these things on animals. Another thing is it can be ignitable. So that means if it is less than 60 degrees Celsius, then the vapors can ignite. It can be corrosive, so it breaks down metals. It can be explosive or highly reactive. So anything that meets any of those criteria is hazardous waste. And here's what the US Academy of Sciences, of which the California Academy of Sciences in San Francisco is a part of, what do they recommend for reducing these hazardous wastes? Because they are a problem. Oops, I skipped. Sorry, I don't know what happened. Let's try this again. Oh my goodness, I'm having trouble with my slides. Okay. There we go. The Academy of Science, what do they say? They say produce less. That's always the best choice. Convert as much as possible to less hazardous substances. So you've got an acid, you can neutralize it with a base, so then it's less hazardous. And then whatever is left, whatever you can't convert to less hazardous, that goes into long-term safe storage, which is what you see in this picture. Very expensive to do this. So the best idea is to make less of it. I would like you to see a video. This is very historic. Love Canal in New York. This is an example of a terrible way to deal with hazardous waste. So you'll pause this video. The link is in your notes. Watch the video and write notes in the table. So after Love Canal, which was a terrible tragedy, the US government passed a law. It was the Resource Conservation and Recovery Act of 1976. The 1970s was a great year for environmental legislation, a great decade, sorry, not year. And then some of those laws have been amended over time. So this one was amended in 1984. So this is a really comprehensive set of laws that requires the proper treatment and storage of hazardous waste. Makes sense, right? Because we don't want things like Love Canal to happen. So companies have to track their hazardous waste all the way from creating it to eventually how do they dispose of it. So then they can't just dump it into a pit in the ground and they can't just ship it off to other countries. They have to track what happens to it. Great idea. The problem is it only regulates about 5% of all the hazardous waste produced in the US. Shocking, huh? The rest of it is not tracked or is not covered by this law. So here's what cradle to grave looks like. A company produces a chemical, and from the moment they're making it to where it goes and how it's finally disposed of has to be tracked. And it's shown to the EPA and state agencies how it was produced and everywhere it went. So and then finally how it's disposed of. So this really does help reduce the amount of hazardous materials that can get into the environment. Now there's another law that's a very important law. The full name is Comprehensive Environmental Response, Compensation, and Liability Act. But there is another name that's usually used. It's called the Superfund. This is because this law creates a fund that companies have to pay into. So when a company goes out of business and they leave behind their toxic mess, there's some money to clean it up. Now, the problem is it's a very long list of toxic areas that need to be cleaned up. And also, Congress has not renewed this. So companies are no longer paying into this fund. There's still the sites that need to be cleaned up, but there's no money going into the super fund. So what it's supposed to do is clean up and remediate, so make it useful again, these abandoned toxic waste sites. And there's this national priority list. So the worst sites in the world, the most polluted places, get put on the Superfund list. And because it's not well funded, most of them just sit on the list and don't get cleaned up. So I want you to see the waste sites we have in California and then in the Bay Area. There's 94 Superfund sites in California. And then the Bay Area, here's our sites. There's the Concord Naval Weapons Station, United, I don't even know how to pronounce that, in Richmond, and another one in Richmond, Oakland, Alameda Naval Air Station, and Hunters Point. So notice it's companies and it's military bases. A lot of it is because they didn't realize long ago that they shouldn't just dump toxic things into the ground. Really, nobody, now we think, how can you not know that? But back then they really didn't think it was a big deal. Dump it in the water, dump it in the ground. You don't see it anymore. It's okay. And now we realize that's not the case. But I want you to notice something else. Where do you find most of these places? They're usually in poor areas. This is another example of environmental justice or social justice. Is it's kind of twofold. Where do these companies go? They go into the poor neighborhoods where people are so swamped working as hard as they can that they can't rally and say, no, we don't want you here. Or the poor people move into the polluted areas because that's where the rent's cheap and they can afford to live there. But just because you're poor, should you live in a polluted area? No, absolutely not. So this is something we should all be working on. How can we prevent, even if you're poor, you don't need to live in a polluted area. So disposing of hazardous waste is always an issue. And what a lot of wealthy countries do is they ship their hazardous waste to low-income countries that are willing to accept it. So back in 1989, there was the Basel Convention. And that's where they said it is illegal for wealthy countries to ship their hazardous waste to low-income countries. So three countries in the world did not ratify this. This means it went back to their government and the government said, yes, we agree to the Basel Convention. The US is one of them. And look who's with us, Afghanistan and Haiti. Is that really two countries that we want to be associated with? So now, the US, Afghanistan, and Haiti did not ratify the Basel Convention, but even more wealthy countries, they also continue the practice illegally. So here's a picture in the Philippines of a protest to Canada. Canada did ratify the Basel Convention, and yet sometimes their toxic waste does get shipped to other countries. So I want you to see what a problem this is by watching this video about what happens to our electronic waste, which is very hazardous. The computer you are using right now is hazardous waste, and you should know what happens to it. So watch this video. The link is in your document, and take notes as you're watching. There's a table for you to write your notes in. So one more piece of legislation I want you to know about. This is really exciting legislation signed in by President Obama. So the way our country worked is chemicals were considered kind of like our legal system. You are considered innocent until proven guilty. And the same thing with chemicals that are sold here. They are considered healthy unless proven guilty. And who has to prove them guilty? The US government. The government has to fund all of the research to prove that a chemical is dangerous. And the government doesn't have enough money to do that, and it takes a lot of time. European countries, it's different. There, if there's any question about the safety of a chemical, the company that sells that chemical has to prove it's safe. That makes sense, right? They're making the money from selling it, so they should prove that it's safe. Not in the US. The government has to prove that the chemical is unhealthy. So in the history of the United States, do you know how many chemicals have been at least partially banned? 5. That's it. Just 5. So May 24th, 2016, President Obama, and this was both parties were 100% behind this law. It was a great cooperation between our government parties. They replaced that old law that said innocent until proven guilty. They changed that. And so now chemicals, this only it pertains to new chemicals that have come onto market after 2016. They have to be tested and found safe before they're allowed to go onto the market. So they can't be sold until they have been proven safe. So that is a very, very good change. Unfortunately, it doesn't impact the thousands of chemicals that were on the market before the law was passed. But going forward, this is a good thing. And now the EPA has the authority to order the testing of chemicals. So if there's any question about how harmful a chemical is, the EPA can say to the company, you've got to test this, even if it's on the market. It does take years of testing, and these companies are biased. So it takes a while to get a chemical off the market. But now that can finally happen. All right. Once you have finished your notes, please submit them to Canvas, and I look forward to seeing you in class.